Hello, and welcome to Hydescience Lab Series episode number 5. Today we are talking about the serological pipette. So today's activity that we are doing is modeled after Biorad's activity 2B, I believe it is, in their textbook. Have modified it slightly a bit. We created our own data tables and our own set of kind of protocols. But basically how this works is that we know the density of water at room temperature is 1.0 grams per mil. So we've been learning about percent error, we've been learning about our skills. So now we're going to test how good we are versus a theoretical yield. So because we know the density of water, that we know that any amount of water in milliliters is equal to its mass at room temperature. So if we have 2 milliliters of water, it should equal 2 grams. If we have 5 milliliters of water, it should equal 5 grams. So using this knowledge, we are going to pipette out some liquid water, and then we are going to take the mass of it, and then we'll use our percent error formula to determine how accurate we were with our pipetting skills. So to kind of just an overview in the yellow here, I know you can't make this out, so these are all our theoretical yields and what we should end up with at the end of this. So this is a great time to talk about kind of variability in equipment and how that could impact something we need to be specific with. So we start with our scale, and we will use a container in which we will put on the scale, and we'll tear that container out. Then we start by taking our empty test tubes and getting the mass of that. And we'll do this for all 5 of our test tubes when they are empty. And what students will notice is that it's not always exactly the same. There is variability in the mass of these test tubes. So this could throw off our results if we did not take this into account. So we'll do that, and then we will pipette out specified amounts. We do 2, 3, 4, and 5. So we learn how to use the pipette. We also use a manual pump, but we will draw our liquid up into the container, and then we will load it into our test tube. And then we will take the new mass of that specified amount. We'll repeat this, 2, 3, 4, and 5, and fill out our data table. And then once we have done that, we will use our percent error formula here, in which we will mathematically see the amount of error we made between our experimental yield, which is what we did, versus theoretical, what we should have got based on the density of water being 1.0 grams per mil. And then we discuss as low percent error is good, high percent error is bad. That's what we're doing in the lab today. This is episode 5. I will see y'all for episode 6.